Okay, this video is for section 10.3 and the vocabulary is a little bit shorter. We can get to some exercises related to what we're doing, but again, just a little variation. The thing that I want to comment on first of all here is that in the previous section 10.2, we talked about a relationship between an angle and an arc, specifically a central angle. We said that if you're given a central angle, which means the vertex has to be at the center and the sides have to be radii, whatever the measure of the angle is, that's the measure of the arc. Okay, those two have to be the same. Okay, always. Okay, now what we want to do is we want to look at another type of angle. This is, like I said, a central angle. Okay, and again, the focus on how we categorize these is where is the vertex of the angle at? If the vertex is at the center, then the angle and the arc are equal. Okay, the second one here, okay, we're going to move the vertex of the angle so that it's on the circle. And this time, instead of radii, the two sides of the angle are going to be chords. Okay, now, whatever this is, okay, this is going to be twice as big. Okay, this is referred to as an inscribed angle. When the vertex is on the circle and both of the two sides are inside. In other words, they're chords. We're going to have some variations of this in just a little bit that aren't inscribed, but still follow the same rule. Okay, so there's two ways they're going to go about doing this. Okay, so for example, here is a circle. If I tell you that this is 70, okay, then find x. That means that x has to be 35 degrees. Or if I give you a circle and let's draw it something like this. If this is 20 and it says find x, okay, then that means to go from angle to arc, I want to double it. Okay, so either way, 2 times the angle will equal the arc. Or, moving that around a little bit, the angle is always equal to 1/2 of the arc. Okay, so that's the premise for this entire section here. You're going to do some variations of that in the exercises, but ultimately that's the rule that you want to apply. Okay, they're going to set up some special kinds of inscribed figures, but we can tie this rule in no matter what we're doing. Okay, so on the first page of the Reteaching with Practice, okay, down on the bottom, number 3, I see that my inscribed angle here is 90 degrees and it intercepts an arc that's identified as 4x plus 8. Okay, so I know that 2 times the angle equals the arc. So 2 times 90 equals 4x plus 8. So you get 180. Subtract the 8 over and you get 172. Divide by 4. And then x is 43. Okay, set them all up something similar to that. Okay, on the second side, probably the thing that I want to make mention of. Well, I'm going to talk about one out of each one of these. On 4, 5, and 6, okay, one of the theorems they talk about says if you have two different inscribed angles that each intercept the same arc, then the angles have to be equal. So notice if you take the 5x minus 2 and follow it out, it goes here to here. Okay, we'll take the 4x plus 9 and follow it out. Okay, either way, you're talking about the same arc. So if the arc is the same in both instances, then guess what? The angles also have to be the same. So you can set them equal. 5x minus 2 equals 4x plus 9. I'm going to subtract the 4x this way. So x minus 2 equals 9. And then add the 2. So x equals 11. Okay? Seven through 9, in each one of these examples, the thing to note would be that you have an inscribed quadrilateral in each one of these cases. Okay, so that inscribed quadrilateral contains 4 inscribed angles, and what has to happen within those is, since they all put together cut off the entire circle, then the combination of those angles has to equal 360, because the combination of the arcs is going to be 360. Okay, so the idea, I think even probably better, is, as it says up here, the opposite angles of an inscribed quadrilateral have to be supplementary. So that's what they did in this example, okay, is they took the opposite angles and set them equal to 180. So on number 9, one pair of opposite angles is this 3x and this 90. So I know that 3x plus 90 has to equal 180. That's what makes them supplementary. If I do the same thing on the other ones, okay, then that means that 2y minus 3 plus y plus 5 has to equal 180. Sorry, running off the page here. Okay, so subtract the 90 over. So I get 3x equals 90. Divide by 3, x is 30. Over here, okay, again, add them up, combine the like terms. A 2y and a y is a 3y. A minus 3 and a plus 5 is a plus 2. I'm going to subtract the 2 over. So I get 178. I'm going to divide by 3. And I get 59.3 repeating. Trying to find a good way to express that. So I guess 178 divided by 3 works. Okay, so hopefully they don't all work out messy answers like that. But again, when you see a quadrilateral inside of a circle, set those opposite angles equal to 180 and then solve for x and y. The variables will be set up to work that way as well. Okay. Practice A. The next worksheet. Again, you start out like we did on the reteaching. Okay, just remember, if you're given the angle, okay, then double it to find the arc. If you're given the arc, double it to, or half it to find the angle. On number 4, okay, 4 is right here. We're trying to find the measure of BC. If A is 90 degrees, then BC is 180. Means it's going to be a semicircle. Okay. On 7 through 14, okay, this time they're going to stick it inside of a triangle, you got a quadrilateral again. So work several of those things into this. Okay. Some cases you have angles, some cases you have arcs. Be careful. So if I know that this is 120, for example, then that's the arc for this inscribed angle. So half of it has to be 60. Okay. And then if this is 120 and this whole thing is 180, that means that this is 60. And then half of that would be 30. And since this is a semicircle, this is going to be a right angle. It cuts off a semicircle, so it's 180. Half of 180 is 90. On 15 through 17, it says excuse me, decide whether a circle can be circumscribed about it. In other words, can you put that thing inside of a circle? Well, you can if the opposite angles are supplementary. If the opposite angles are supplementary, then you can say yes. Okay? Well, if this, I have a quadrilateral here, 360. Okay? So these two, I can see add to 180. And whatever's left for, they don't have to be equal, they will be, but they don't have to be. Whatever's left for these other two, then also has to be 180. So since both pair of opposite angles are supplementary, then I would say yes, this thing can have a circle circumscribed about it. And then same idea down below. You've got some angles, quadrilaterals, okay? Use the theorems that we talked about on that reteaching with practice to find the missing values of x, or x and or y, okay? So similar to one we've already done, okay? So I think that gives you a pretty clear picture of what you need to do here. Again, if you have specific questions, okay, email me and I can address those, help you out a little bit, okay, and then maybe get to where you complete them, okay. So again, don't wait for a due date. If you get it done early, submit it at the next drop-off time, and then I'll just keep grading and getting stuff back to you in preparations for that final test. We have 3 units yet to cover and then take that test. Thank you.